The world as we know it is governed by laws discovered by Isaac Newton centuries ago. Apples fall from trees, planets orbit stars, and what goes up must come down, all thanks to gravity. But what happens when we shrink ourselves down to the size of an atom? The world transforms into a realm of perplexing paradoxes, the quantum realm. Welcome to the world of quantum mechanics, where the universe isn't as it appears. In this strange land, particles can be in two places at once, blurring the line between matter and energy. Here, our everyday intuition breaks down, and we encounter phenomena like quantum entanglement, where particles are linked across vast distances. These particles communicate instantaneously, whispering secrets that defy the limits of speed and distance. Quantum mechanics is not just a theory, it's a revolution that has fundamentally altered our understanding of the universe. But don't worry, you don't need a PhD in physics to grasp the basics. In this exploration, we'll embark on a journey to demystify quantum mechanics, making it accessible and engaging. We'll unravel its enigmatic principles, uncover its real-world applications, and peer into the future it promises to shape. So fasten your seatbelts and get ready for a mind-bending adventure into the heart of quantum mechanics, where the seemingly impossible becomes possible, and the only constant is change itself. Prepare to be amazed. In the world of quantum mechanics, certainty gives way to probability. Unlike the predictable motion of planets, the behavior of subatomic particles is inherently uncertain. Imagine flipping a coin. You can't know for sure whether it will land heads or tails. Similarly, in the quantum realm, we can only predict the likelihood of a particle's state, not its exact location or momentum. This inherent uncertainty is not due to a lack of knowledge or limitations in our measuring tools. It's a fundamental property of the quantum world. The famous Heisenberg uncertainty principle states that the more precisely we know a particle's position, the less precisely we can know its momentum, and vice versa. It's as if the act of observation itself influences the particle's behavior, blurring its reality. This probabilistic nature of quantum mechanics challenges our classical intuition. Instead of neatly defined trajectories, we have wave functions, mathematical descriptions that represent the probabilities of finding a particle in various states. These wave functions evolve over time, like ripples spreading on a pond, reflecting the ever-changing nature of quantum systems. The world of quantum mechanics is a dance of probabilities, a cosmic symphony where chance and uncertainty reign supreme. But within this seemingly chaotic realm lies a hidden order, a set of rules that govern the behavior of the very building blocks of reality. One of the most famous experiments in quantum mechanics, the double-slit experiment, beautifully illustrates the perplexing nature of the quantum world. Imagine shining a beam of light at a barrier with two narrow slits. Classical physics predicts that the light will pass through the slits and create two bright bands on a screen behind it. However, when we actually perform this experiment with particles like electrons, something astonishing happens. Instead of two bands, we observe an interference pattern on the screen, a series of bright and dark fringes, as if the electrons were interfering with themselves. This pattern suggests that the electrons are behaving like waves, spreading out and interfering with each other as they pass through both slits simultaneously. But here's the catch. Even when we fire electrons one at a time, the interference pattern still emerges. It's as if each electron somehow knows about the existence of both slits and chooses to travel through both at once, interfering with itself along the way. This mind-boggling phenomenon, known as wave-particle duality, lies at the heart of quantum mechanics. Particles, like electrons or photons, can exhibit both wave-like and particle-like behavior, depending on how we choose to observe them. It's a profound concept that challenges our classical understanding of the nature of reality. Quantum mechanics may seem like a strange and esoteric realm, confined to the laboratories of physicists. However, its principles underpin many technologies that have revolutionized our world. From lasers to medical imaging, quantum mechanics is not just a theoretical curiosity, it's a practical tool that shapes our everyday lives. Lasers, for example, rely on the quantum phenomenon of stimulated emission, where energized atoms emit photons of light in a synchronized manner. This coherent light has unique properties, enabling applications in telecommunications, barcode scanners, and even laser surgery. Medical imaging techniques such as MRI, magnetic resonance imaging, harness the quantum properties of atomic nuclei to create detailed images of the inside of the human body. By manipulating the spins of these tiny particles, doctors can diagnose and monitor a wide range of medical conditions, from torn ligaments to brain tumors. Quantum mechanics also plays a crucial role in modern electronics. Transistors, the building blocks of computers and smartphones, rely on the quantum behavior of electrons in semiconductors. As technology advances, researchers are exploring the potential of quantum computers, which exploit quantum phenomena like superposition and entanglement to perform calculations that are impossible for even the most powerful classical computers.